Good morning again, ladies and gentlemen. Welcome to BASF. Welcome to our plastics journey. This is our second plastics dialogue for today. Out there in all the other halls is just exhibits, but here it's exchange. Yeah, and I'm happy to exchange with my co-panelist this morning. Let me introduce you to again Katharina Bening, professor for circular economy and net zero at ETH Zurich. Thomas Scheller from ZF LIFETEC, and my colleague from BASF, who is the one person who manages to explain circularity so that even I understand it, Jens Hambrecht. Thanks for being here. Good morning. I hope you're having a good day, everybody.
Hello, good morning.
Hi, good morning. Fantastic. So we're talking about steering circularity in the automotive industry. Complex topic, and it all starts with waste. And I'm going to start with you in that sense. Why is waste important for ZF?
Yeah, there are several reasons why waste is important. First, I think I don't have to talk so much about coming regulations because everybody's aware that we will have end-of-life regulations in the automotive industry. That's definitely a point. But waste itself, we have post-industrial waste in our production. For example, when forming a steering wheel, you have these mushrooms that you have to pick from the mold out of the vents. So later on, when you go around the corner, you can see what I'm talking about. And these make a lot of waste, and we have to tackle it. We have to work with that waste and do something. And that's why, yes, we have a lot of waste, so we must do something.
Okay, that is also a new kind of approach, of course, because in the past this wasn't the case, and now this is a valuable raw material.
Yeah, exactly. So also if I say waste, this changed. It's no longer waste, it becomes raw material again. Yeah.
You mentioned the end-of-life vehicle regulation. How much plastic is actually recycled plastic goes into new vehicles nowadays?
Is that to me?
Yeah, I think so.
Unfortunately, very little currently. Thanks for the question. I think it's approximately, depending on the numbers you want to trust, 3%. I think that's still very optimistic, so there is a lot to do.
Okay. And what?
Everything.
Okay. All at once.
All at once,
Yeah.
ideally. So I think what Thomas was mentioning earlier, the recycling of post-industrial is one. Post-consumer, probably much more difficult, is the other. But then not only the waste stream that you're tackling is one, but also the technologies that you want to employ. So I think, and whatever is there for circular economy. So it's not only recycling, it's certainly also remanufacturing, the reuse of spare parts and so forth and so on. So I think we need it all. And colleagues of ours, there the numbers are.
Okay.
Great. Colleagues of ours have done a study. So if you want to stay within the planetary boundaries for plastics, we will need like everything from gasification, pyrolysis, depolymerization, everything until 2030, scaled up to 70% of recycling. So to contrast these numbers, 3 and 70, that's a lot.
And we have 5 years?
Yes, I guess so.
From now on? Okay, that's challenging. Jens, please unpack the different waste streams that exist and what we can do with it for us a little bit.
So we have in Europe a total of a little over 30 million tons of plastic waste that we generate each year. And when we're looking at post-industrial waste first, that's close to 3 million tons. And if you ask mechanical recyclers, what's the volume of plastic waste you process every year? Well, it's around about 10 million tons of plastic waste. But that shows you just how much of a potential there is still left. 10 million tons that go into recycling plants, a total of 30 million tons of plastic waste. So there's a lot of tasks ahead of us to tackle.
And what happens to that waste nowadays?
So the 10 million tons that go into mechanical recycling, the recyclers make 7 million tons of recyclate out of it. And all the other 20 plus million tons, unfortunately, they either go to incineration or to landfilling.
Thomas, how much waste do you have in your production?
I think I will stay at the
figures for us, maybe?
Yeah. I stay at the example of the mushrooms I mentioned in the beginning. So it's about 1,000 tons a year that we have.
Okay.
So that's quite a bit, for sure, depending on how many steering wheels we build. But I think that's a good number. And for this, we already have a cooperation with BASF ongoing, our recycling polyol project. So it's also about mechanical recycling, what was mentioned. The principle is simply explained. We collect our mushrooms, they are shipped to BASF. BASF makes the mechanical recycling, creates a recycling polyol, puts it into a new formulation for foaming, and this comes back to us. So by that we can already create a waste circle, let's say, or a not waste, material circle.
A circle. Let's just call it circle.
Yeah.
Exactly. You mentioned mechanical recycling. Of course, there are many, many different routes. Jens, what's the potential of mechanical recycling, but also shed some light on the other recycling routes that exist?
So when we look at mechanical recycling first, I'm convinced that mechanical recycling will grow for 3 reasons. The first one is design for recycling. So for example, as BASF, we've now realized as a world first to make polyurethane, soft polyurethane, mechanically recyclable. The second reason why mechanical recycling will grow is progress that we have in AI-driven sorting, so it becomes more economic to sort it out, but also the additives that allow us to increase the number of times a plastic gets recycled. You see these on our booth here as well. These also help our progress. But having said that, my point of view is that mechanical recycling alone will not bring us to circularity of plastics, but I'm looking forward to your points of view on that.
Katharina, what's your point?
I think I can only repeat myself. So I think we need it all, as you said, ideally within the next 5 years. Well, I think what also is shown in this graph, and that is a huge potential, is that half of the waste that we have from cars is currently lost or unknown, as we call it. So I think only from the waste stream there is huge potential, and I think AI will do a lot in terms of tracking and tracing. And then we see we can witness a grow in terms of remanufacturing. Then there will be mechanical recycling, but then we have automotive shredder residue, which has not been treated so far massively. Thank you very much. So that's a buzzword. And that's exactly what we're looking into right now with new technologies. For example, co-gasification of this material, which is currently backfilled or burned, as Jens said earlier.
Thomas, is this also an option that you are exploring, that you are looking into? I mean, look at this.
Yeah, together with BASF, we also looked into that. So I think BASF made a cooperation. And by mass balance, let's say as drop-in solution, we also already foamed some steering wheels with material by that pass. It was an, let's say, easy drop-in for us technically, let's say technically, because I think bureaucracy is another story.
Okay.
But as there was no chemical difference in the components, so it was identical. We were not even able to distinguish it. It's a drop-in solution for us, definitely.
And Jens, what about the kind of products that you can generate from these waste streams? Are they all on the same level as a virgin product, or are there differences?
Yeah, indeed. So gasification as a technology, what it yields us is a feedstock. And this feedstock we feed into the BASF Verbund. And then following a mass balance approach, we allocate it to the product lines that use it. And this results in exactly the same material characteristics that you are used to from the fossil feedstock. And to me, the key part is this is now even officially documented, because when we did this project for gasification that we'll talk about, the authorities approved that the material that we processed no longer has a waste status. So they looked at the chemical feedstock that we produced out of it, and they realized, yes, this has really the characteristics, the quality criteria that we know from conventional feedstock. And therefore, for the first time, shredder residues has been transformed into a feedstock with official recognition of that.
How important is that step? You mentioned it is for the first time, but is this really groundbreaking and paving the way into the future? Katharina, what's your take?
That is definitely groundbreaking.
Yeah.
Thanks for the question. Because, I mean, if it's not accounted for what can be saved through this loop, then there probably is no business case and also no incentive to invest in this. So Jens has been mentioning one crucial point, so the eligible waste stream. But there are many more open regulatory questions that have to be solved and will probably be solved partly by the end-of-life vehicle regulation. but there are many more open questions.
Can you mention a few for us?
Yeah, for example, the question is the mass balance approach that Jens was mentioning earlier. So the allocation methods are very different and yield very different results, and this is very much open to where this will go. Obviously, currently we have the exempt fuel use paradigm. If that will hold in the future, that will also have a huge impact in terms of investments in the technology. And all this is debated currently, so that's a very interesting time, not only for industry, but also for the research.
Yeah, but I can imagine, Thomas, that this interesting time for the industry also is not an easy time, because you somehow need stable framework conditions. You need to know where the path is going in order to do business, right?
Exactly. So it's also true, we need, from our side, also customers to say we want that, who go with that, so we have a volume to calculate with. And I think that's the same for BASF. They also need to know how much do we need, how much can we make. And this is the big point. As I mentioned, from technical side, as drop-in solution, this was an easy one, or is an easy one.
The terminology, let's say, has changed a little since circularity has become so big also in the automotive industry. Maybe a bit more as a background question, how different is your communication within the projects now that topics like gasification, depolymerization, things like that are top of the agenda? I imagine probably conversations at ZF were a bit different 5 to 10 years ago.
Yeah, definitely. But yeah, at the moment we are focusing on the recycling polyol project, what I mentioned, so chemical recycling. This is really our first step, because that's something that we have in hand, that we can control. But I think topics for post-consumer waste, this is the challenge that is coming. So we're just at the beginning with the first step, but the other topics also have to be tackled. And we are glad that already preparations are made, let's say.
Preparations are made?
Exactly. So this topic of shredder residues, the challenge that we took on is to have this as feedstock, to enter it into a gasification process alongside biomass. And this we have realized for the first time at global scale. It's a process that hadn't been realized before, and we've been looking for partners globally to realize this project. And we found this partner at BEST GmbH in Vienna. And what we did there was to process shredder residues and biomass. Initially, we wanted to draw on shredder residues from France. But then I learned about European waste shipment regulation, and that it's really complex to get shredder residues from one country to another. So in the end, there was such horrendous paperwork that we chose a different fraction of shredder residues produced in Austria. And for multiple days at a large scale, we processed this alongside biomass to produce really for the first time a completely non-fossil feedstock based on shredder residues. And then we fed this into our production process, and I'm happy to hear you could process it so well.
That's good. And this whole project also generated quite some attention since then, no?
Yeah, so we had an article yesterday in the Frankfurter Allgemeine Zeitung, half a page on it, and I'm happy to see that there is interest picking up on the opportunities that really come along with these new recycling technologies. And to really make use of these new technologies, it's not just a matter of technological innovation, as Katharina mentioned, it's also a matter of regulatory innovation. So these concepts such as mass balance or acceptance of this recycling technology, that is really essential to boost the recycling rates in Europe.
You mentioned that. One more part is certainly also education, I would say. This is also the feedback that we're getting here from the colleagues at the booth. A lot of this is still new and it's complicated. Katharina, how important do you think education is also, let's say, on a public understanding of science base?
Wow, that's a big question.
Yeah, that's why we have you to answer it.
Great,
Exactly.
thanks. Well, as a teacher, I think I am all up for education.
I listen.
Yes, I am. I think an interesting observation in terms of the research that we do, and that leads to the public education, is that the paradigm that we had maybe 5 years ago, that mechanical recycling and any chemical recycling would be in competition, I think we have overcome that paradigm. And I think that's a huge step. Coming back to what I said earlier, we will need all of the technologies, ideally at once. I think this kind of education or insight that has developed is a huge step. And I think, especially in Germany, there is a huge favorism for technology agnostic solution, as they call it, especially.
Technology agnostic is the word?
I think that's what is very favorite these days, especially in the car industry. I am not, but I think that's a term. And I think this technology openness, let's call it, when it comes to recycling is very important. And so there is still a lot to do in terms of education, backed by research ideally, but that's my business, to come forward with projects like this to say, okay, what is the LCA on this route? What can we actually do? But also the question, as Jens said, what is actually allowed and what is feasible? And there is much more open space than you would imagine.
Thomas, on the topic of education, or also on the talents that you need in ZF, the talents for tomorrow, how do you see their background, maybe also their vision has changed for a circular future? Are you observing something there?
How do you mean it? So
you see young people joining ZF with a much more circular state of mind already?
I think the mindset changed a lot in the young generations. So, like separating waste and everything, I think this is more common with the younger people. And I hope this will also be more common in the companies they work in, to have the right spirit there. Because, coming again back to our mushroom topic, if we sort them properly, then the raw material is there. If we mix it in the facility or in the factory with other waste streams, then it's difficult. So education is definitely important and needed, because if the waste has a clear stream, then you can use it more easily, and also for mechanical recycling.
And actually, if you haven't been there, I can highly recommend our little recycling explanatory piece that we have at the back of the booth, where you see the different waste streams sorted. I'd like to hear from you an answer to one last question, and you have a couple of seconds to also give me a reason. On a scale from 0 to 10, how optimistic are you for a circular future in the automotive industry? Thomas?
I would say 8.
8? Solid 8, yeah? Why?
I'm optimist.
Oh,
and I think we have to. That's why I say 8.
Okay. We have an 8. Katharina?
I give it 10. I give it 10. I think it's a necessity. I would not know any research that would suggest you can do a little circularity, but so I mean there are so many more or less binding international agreements which will force us to go to net zero, and so I don't see many other options. Actually, I see none.
No.
So that's why I give it a 10. You didn't ask for the likelihood of this to happen, but you asked me of what I like to see and what I think is necessary, and that's definitely the
Now
case.
I have to ask about the likelihood.
Yeah, the likelihood? Well, I think that depends very much on geography. I'm still hoping that Europe will realize this early enough and switch to my 10 answer now. Or otherwise, I think there are so many other countries already preparing for the 10 answer that they will just be overtaken. But that comes back to the technology openness that especially the German government is currently discussing, and I think they should decide on this very quickly.
Thank you.
I think it's a 10 long term, and the task for us is really to get together, to have this collective action across our industry to encourage also our regulators to make the framework we need to have the 10.
Okay. Thomas, Katharina, Jens, thank you very much for your time this morning. You're going to stay with us for a couple of more minutes, so if you have any more questions, feel free to approach our 3 experts here. That was our second plastic dialogue for today. Thank you all for joining. Biggest crowd so far, because it's a meaningful topic, it's an important topic. Thank you for your attention. We'll be back in 45 minutes from now. Bye-bye.
Thank you.
BASF. We create chemistry.